Hi, and welcome to another lecture on business mathematics. Today we are going to start a new topic, exponential and logarithmic functions. This is going to be part one of several lectures. So we are going to get familiar with the following functions that I have written here: b to power of x, logarithm of x in base b, e to the power of x, and natural log of x. A motivation for studying what we are going to do today is that all these functions come in when you go through a purchase which results in installment payment. As you want to calculate how much your payment is going to be every month, these functions are going to come in. So they are all related to the idea of compounding interest, something that you are going to be definitely dealing with in your future business classes. So let's start with the simplest of these and most familiar of them, b to power of x. So what is meant by that? So what we are going to study first is what is the meaning of this notation. Let's go ahead and choose a specific number so that everything is familiar to us. So this number is referred to as the base. That's why we are using the letter b. But here let's try to use the base 2 to power of x. So what is meant by this? The idea of a compounding really boils down to multiplying by the same number over and over again. So interest on a principal gets added to the principal, and every month you go through compounding, which means multiplying by the same number. The numbers in business world are, of course, all kind of decimal numbers and such. To make the matter easy for us to follow, we are going to use some whole numbers, so bear with me while I do that. So we said the idea of compounding is to multiply something by itself several times. So if you take 2 and multiply it by itself 3 times, so we have 3 2's multiplying each other. We abbreviate this thing. Of course, 2 times 2 times 2 is 8, but another way of writing this thing is 2 to power of 3, which is in fact 8. Now what if you have 2 times 2 and you want to multiply many times? Well, you kind of get tired writing it, so you use these 3 dots, ellipses, marks to indicate how many times you want to multiply. Let's say this is 10 times. So I might not actually write them all out because that's going to take forever, but the shorthand for that would be 2 to the power of 10. If you are on your search bar of your browser and you want to calculate this thing, the way you write it there, of course there's no room there for typing in this style. Inline, they use a notation like this. So calculators, each of them have a kind of a notation for how you type in this type of operation. So most common is to use this hat to indicate that you want to raise a number to a certain exponent. So this is referred to as a base, and this is referred to as the exponent. So again, this is the base, and this is the exponent. Another notation you might come across, perhaps calculator or computer program and such, they might use double multiplication sign next to each other to indicate what they want to do. Okay, 2 to the power of 10, what is that going to be? So while we sit down and multiply, and it's a good idea to memorize powers of 2, as far as you can go, that would be great, but 2 to the power of 10, if you multiply it out all out, you get 1024. And higher powers of they do come in when you do computer purchases and such. So in the computer languages, sometimes they refer to this as 1K. Now K for kilo supposed to be 1000, but in that context, this is also referred to as 1K. So these are the type of numbers you come across in the computer world, quite common. Now, once we have a notation, uh, we have new toys to play with, and so we have this type of numbers. We call them exponential numbers. So this is exponential. Exponential numbers simply means a number that is written by exponential notation. Well, once you have numbers, you want to know how to add them, multiply them, divide them, and so on. And we have certain kind of rules that apply to these particular exponential numbers. The first of these things is, what if I have one exponential number and I multiply it by another exponential number, and they both have the same base? So remember, the base is the number at the bottom. So easiest way to tackle this type of question is to write it back as to what it meant. 2 cubed, so that's another way of referring to this thing. If the exponent is 3, it gets to be nicknamed as cube. 2 cubed means 3 of these things. And 2 to the power of 5 means you have 5 of them. And since you are multiplying these, now you can say, I string them all together. Well, how many do I have? Well, I have 3 here and a 5 here, so I have a total of 8 now. So here is, we have our first rule, that if you are multiplying exponential numbers with the same base, then you add the exponents, and then you have 2 to the power of 8 in this case. In general, if you have b to some exponent n and another b to some exponent m, when you multiply them, you get b to the power of n plus m. So here we have a multiplication, and over there we have an addition. Sometimes when trying to memorize these things, they get it wrong or misapply them. Like, what if I had 2 to the power of 3 plus 2 to the power of 5? What can I do here? Well, this is true that this is 2 times 2 times 2, and this is still 2 times 2 times 2 times 2 times 2. But now you're adding them. There's one story, if you're multiplying them, now you have a string of 8 of them, so it's 2 to the power of 8. But hence, since you're adding them, it's not as simple or easy, and there isn't much you can do here. Perhaps you can factor or something, but no similar rule applies here. So one way to practice these things is to go back and write a small case example and see what makes sense in that situation, and then not to go overboard with the following cases. This is not 2 to the power of 8 or anything similar. No similar rule applies here. You could factor 2 to the power of 3 if you wish, but that's not our point in this case. What if you were dividing them? So what if I have 2 to the power of 5 over 2 to the power of 3? Well, remember, again, we go back to what these things meant. So this is 5 of them, and now I have 3 of them in the denominator, and we can cancel from numerator and denominator. And what's left? Well, there were 5 of them. It took out 3, so it's 5 minus 3. So 2 to the power of 5 minus 3, which is 2 to the power of 2, and this is referred to as 2 squared. So cube and now squared. Well, that gives us the idea that if I have b to the power of n over b to the power of m, and I can go ahead and subtract the exponent. Interesting situation arises if I do this thing the other way around, 2 cubed over 2 to the power of 5. These are the same numbers, just we are changing their location. So as before, 3 of them cancel 3 of these, and all I'm left with is 1 over 2 squared. However, if we weren't paying attention as to how many are in the numerator and denominator, and you apply this rule, we would have written exponent of the numerator minus exponent of denominator, which is going to be minus 2 now. Now, to make everything work, we are going to interpret a negative exponent as a fraction where there's a 1 on the numerator, and we have the same exponential number with a positive exponent. So if I have b to power of minus n, I cannot make sense of that in saying, let's write a number minus 3 times. That doesn't make sense. To make sense of it, we come and say, well, it could be defined b to power of n to be 1 over b to power of n. So meaning of a negative exponent comes out here. Another example, what if I had 2 cubed over 2 cubed? Well, these two numbers, whatever they are, they're the same, and if you're dividing them, you have to take just get 1. On the other hand, if you apply this rule, you are going to have the exponent of numerator minus exponent of denominator, and the exponent is going to be 0. So we have another rule that base to power of 0 is going to be defined to be 1. Again, notice if I say 2 to the power of 0, what's the meaning of it? It just means the number of 2's that you write is 0, meaning you're not writing anything. So how is that 1? Here we justify why do we do that, so that this rule applies in all cases. So let's paraphrase what we had. B to power of n times b to power of m is b to power of n plus m. B to power of n divided by b to power of m is b to power of n minus m. This led to 2 observations. If you have a negative exponent, that means you have a fraction with the same positive exponent in the denominator. And then if you have power of 0, that's just 1. These are the basic rules, but there are some additional that I'm going to explain, and then add them to this box of rules that we have. So what other rules do we have here? Well, suppose you have 2 to the power of 3, and then to power of 2. What does this 2 mean here? It means whatever this whole thing is your base, and that is multiplying by itself twice. So I have 2 cubed, it's 1 round, and then another 2 cubed, that's a second round. So now I have to add 3 and 3, which is 2 3's. So I can write this thing as 2 to power of 3 times 2. Is that right? Instead of saying add 3 and 3, I can say multiply 3 by 2. So what does that tell me? What that tells me is that if I have an exponent, exponential number wrapped in the parentheses, and I have another exponential number, to simplify it, we multiply the old and new exponent, so I'll have n times m. Let's practice this thing again. Suppose I have 5 cubed to power of 7. What does that mean? It means take 5 cubed, write it 7 times. It's going to be a bit tiring to write that, but we can do it. 5, that's what it means. Well, if you want to add up all these exponents, what do you get? 7 3's. So it becomes 5 to the power of 21. So that is the explanation of this. We have to be careful the order of operation here. What if somebody doesn't write the parentheses? What if somebody writes 2 to the power of 3 to the power of 2? What does that mean? Well, One interpretation of this thing is what we had here, that is take 2 to the power of 3 and cube it. But somebody else might say, well, I want to take 3 and square it and then use that as an exponent. Notice this is our old result that we had 2 to the power of 6. However, this one is 2 to the power of 9. Okay, so if I don't have a parentheses, the rule, the tiebreaker between these two is that this is the one that is meant, because for that one we already had the parentheses notation, and so with the parentheses, that's what it means. Without the parentheses, this is the meaning of it. So we have to understand that if I don't have, so if I have b to power of n to power of m without the parentheses, it means that n to power of m has to be simplified first, and then you carry out this. Okay, up to now we always had the same base all the way throughout. What if I have two bases? Suppose I have a b to power of 3. What does that mean? It means ab, ab, ab. Again, we understand what the power notation means. It means base has to be repeated these many times, and they are all multiplying each other. Well, we are going to rearrange, take all the a's and put them together, so that will be a cubed. Put all the b's together, that becomes b cubed. So that's another rule that we have here is if I have a b to power of n, and that's going to be a to power of n, b to power of n. Same rule applies for ratios, of course. If I have a over b to power of 3, that means a to power of 3 over b to power of 3. Let's do a combination exercise here. So if I have a squared b over c cubed d to power of 4 to power of 5, how would you simplify it? This is old exponent, this is the new exponent. They are going to multiply. 2 times 5, 2 times 5 is 10. A number without the exponent means the exponent is 1. Multiply all the new b to power of 5. The denominator, c to power of 15, d to power of 20, and that takes care of that. Okay. Now how about functions? So now next we are going to look at exponential functions. Again, just to motivate and justify what we are doing, if you have a certain loan and say you don't pay the installment, what happens? In next time, same factor is going to multiply your old debt, and then every month it gets multiplied by the same factor. Usually those factors are like 1.07, 1.08 and stuff like that, which are representative of interest rate that you have. But just to make the problem simple, we make our multiplier to be a nice number, just so that our functions are easy. So if my multiplier is 2, and then every month I go and multiply by another 2, I get a function looking like 2 to the power of x. We want to understand what does this function mean and what does it look like. So to understand it, we ask for a graph. What's a graph? Well, a graph, a visual representation of a table. So here I put my x and then my y. We learned that if x is 0, that means 1. If 1, 2 to the power of 1, it just means 2. 2 to the power of 2 means 4. 2 to the power of 3 means 8, and so on. What about negative exponent? What's 2 to the power of negative 1? We just learned that. It means it's a fraction. 2 to the power of minus 2, it means 1 over 2 to the power of 2, so that becomes 1 over 4, and so on. So from this table, let we see that as we go down, every time we are multiplying by 2. As we go back up, every time we are dividing by 2. My numbers are always positive, regardless of what x is. If I want to graph this thing, then I prepare my xy coordinate system. So this is my x, this is my y. Let's graph this one. 2 to the power of 0, so here is 0, and say this is 1. 2 to the power of 1 is 2. Let's say this is 1, and then I'll be at 2. At 2, we are going to be at 4. So as 2, 1, 2, 3, and 4. So we got to 4. At 3, we are at 8. At 3, we are at 4, 5, 6, 7, and 8. So you see that this is escaping, going up quite rapidly. That's called exponential growth. This exponential growth is what is behind the advice of not owning anything on your credit card and paying it off, because if you don't, it just grows very rapidly. How about going in the negative direction? If I go to -1, I go to 1/2. So as you go move left, every step the height of function becomes half of what it was before. At -2 and -2, I'm going to be at 1, so this is going to be 1/2. This is going to be 1/4. If you go another step, so it's -1, -2, -3, and this is going to be 1/8. So if we go ahead and connect these things to each other, what do we get? We are filling in for lots of detail like that. So for example, at 1/2, where are we going to be? That's going to be here. 2 to the power of 1/2. What does that mean? We are going to explain what's the meaning of that. That can be explained like everything else. So next that we are going to study here is a fractional exponents. Fractional exponents. So what does it mean to write 2 to the power of 1/2? We know 2 to the power of 3 meant multiply 2 by itself 3 times. But what does it mean to say multiply 2 by itself half a time? Just like you can have a family cannot have 1.5 babies, even though on average they might. Here, 2 to the power of 1/2. What does that mean? Well, we understand that here is 1/2. 2 to the power of 1/2 is wherever you are on this curve. But what does that number mean? Here we are going to make use of the following. Whatever this is, if I square it, raise it to power of 2, we said all the new exponents are going to multiply each other, and I get 2 to the power of 1, which is just 2. So 2 to the power of 1/2, if for a moment I call it number A is such a number that if I square it, I get 2. That's what happened here. I squared it, I got 2. So what is A? A can be plus or minus square root of 2. And since our numbers are all positive here, the only number that makes sense for us is A to be square root of 2. So here is the meaning of B in any number to power of 1/2. What does that mean? It simply means square root of that number. In same manner, what is the meaning of B to power of 1/3? What that means is that the cube root of B So I write 3 here just to make sure it stands apart from that. So let's go ahead and practice. For example, what is 125 to the power of 1/3? I'm looking for a number that if I cube it, I get 125, and that answer happens to be 5. So now if you have a combination of these, what does that mean? If I have b to the power of m over n, what's the meaning of that? It means take the nth root of b and then raise it to the power of m, or if you wish, take b and raise it to the power of m and then take the nth root of it. They are all the same. In all of these, we are assuming that our base is a positive number. So base is a positive number so that we don't get tangled in with imaginary numbers and such. Okay, so let's go back to see what happened here. We learned how to interpret exponential numbers. We said exponential number simply means that we are multiplying same number by itself so many times. For multiplication, we had a simple rule. For division, we had another rule. That idea gave us two contributions to make sense of negative exponent and to make sense of 0. If you have double exponent, we learn how to treat that situation. And if you had two numbers for the bases, we had certain rules for them as well. So now we had introduced you to some additional rules. Additional rules here is b to the power of 1 over n means simply nth root of b. And we practiced the 2 to the power of x. We said the graph of it looks like a graph of exponential growth. It looks like perhaps something like this. So 2 to the power of x. What if I had some other base, say 3 to the power of x? 3 to the power of x grows faster and also decays faster. When we go to the other side, we talk of decay. When you go to the right, we talk of well, what if I was interested in some number that wasn't whole number? What if about 2.5? Well, why are we looking at that? Because the bases you use in business are like 1.07, 1.08. Those are 1 plus the interest rate that you're compounding. So you always deal with actually not non-whole numbers. It's going to be quite rare to have these kind of things. Well, so if you had 2.5, where would it be? Well, it makes sense that it wouldn't be between these two. Now there are all sorts of numbers between 2 and 3, 2, 2.1, 2.3, 2.5, all the way to 3. Among all of these, there is a particular number which stands out because that function has many interesting properties, and here I'm going to write it. So between 2 and 3, one of the numbers that stands out is a number e, whose approximate value is 2.71828, etc. Is a number that is very highly esteemed in mathematics, just like pi is. And its value is known to millions of digits. And there are various ways of justifying this number. And in fact, one of the first justification of this particular strange looking number comes from the world of business, when people were working with the idea of compounding. So this is essentially, if a dollar is compounded continuously at 100%, then at the 1 year interval, that dollar becomes 2.718, etc. We're going to hopefully explain that sometime soon. But once you have that, then you have exponential function with the base e. Just remember that e is not a variable or anything. It just stands for that strange number, 2.71828, etc., to the power of x. So all calculators that are worth their name as a calculator have this as a button on your calculator, and you want to learn how to use it. So where does the graph of exponential of x sit? Well, it's going to be somewhere higher than 2.5 because it's 2.7, so it's going to be closer to 3. So it's going to be somewhere in between these two, and it's also the other way. So this is exponential of x. It just somewhere between 2 to the x and 3 to the x, and kind of closer to 3 to the x. That's going to be a very important function for us. Okay, so we introduced the exponential. We talked about this function b to the power of x, where b could be any number, and e to the x is a special case of that. Among all these functions, the ones that stand out, 2 to the power of x shows up very often in dealing with computers or dealing with radioactive dating and stuff like that. 10 to the power of x comes up very often when you are talking about somebody having 6-figure salary. You're actually referring to this function. 10 to the power of 6 is 1 million. That is of course 7 digits. Less than that, 999,999, that is a 6-figure salary. So any salary between 100,000 and 999,999, which is just 10 to the power of 6 minus 1, they are referred to as 6-figure salaries. So what is this one? Is 10 to the power of 5 to 10 to the power of 6 minus 1. This is the range of so-called 6-figure salaries. We are going to see same notion again when we are going to talk about logarithms, but hopefully in the next lecture. Until then, good luck and God bless.